Hi, welcome to our pre-calculus. The topic today is double angle identities problem type 1. So you remember the sum and difference identities we worked on in the last couple of lectures. Uh, for the sum, sorry, for the sum, you see formulas of this type: sine of a plus b, or cosine, or tangent, and we had certain formulas on the right hand side. Double angle means what if the two angles are the same? So if A and B are the same, both of them are A, you have sine of A plus A. So it's going to be sine of A, cosine of A, cosine of A, sine of A. When you simplify that, it means sine of 2A will be 2 sine A cosine A. So this terms becomes all A's and you get a simpler formula. Similarly, if you have cosine of A plus B, if A and B are the same, this becomes cosine of A, which you write cosine square of A. This becomes sine of A times another sine of A, which becomes sine square of A. Similarly, for tangent, if A and B are the same, you will have tangent of A plus another tangent of A. That makes 2 tangent of A. Tangent of A times tangent of B, B and A are the same. It becomes tangent square. So these are then called this set that you see here, these are so-called double angle identities. The middle one for cosine has two other reincarnations as well. If we apply the Pythagorean theorem, we can write sine square in terms of cosine square, and then the formula becomes 2 cosine squared minus 1. If you take cosine square and write it in terms of sine, meaning write it as 1 minus sine square, you get 1 minus 2 sine square of A. So these are the formulas that get to be used in various areas of mathematics more and more. You might be wondering if you're actually going to see this in any of your future classes. All engineers are going to see this one very often. And the reason for that is when you look at something like electric current in a wire. When you have alternating current, your voltage goes up and down according to some cosine term or sine term. You typically want to calculate the power in a current, and the power becomes square of the voltage. So you end up with these expressions including cosine square and sine square. And when you want to operate with them, then this formula becomes very handy. So out of all these 6 formulas you see on this page, the one that you see first in perhaps your very first physics or engineering class would be this one. These other forms for sine and cosine, you are going to see them as well in the phenomena of resonance and interesting problems in differential equations. Let's go ahead and do our mathematical practice today. So what are the type of questions we see here? Here is a kind of question, it's common in this section. Some information about an angle is given. For example, sine of an angle is given to be this fraction, and also we are told that our angle is in a certain quadrant. What is it that we are supposed to find? We are supposed to find, well, sine of 2x, cosine of 2x, tangent of 2x, and similar expressions. So I go and see, well, what is the ingredients that I need? If I want to calculate sine of 2x, I need both sine and cosine of a single x. If I want cosine of 2x, I can live with either cosine or sine, or both of them, either of them would be fine. If I'm looking to get tangent of 2a, one way to do that is through tangent. I need the tangent, or I can find the ratio of these two. So multiple ways of getting our answers. Let's go ahead and do some of these things. So first, we try to understand what this tells us. We use that in conjunction with the fact that we know we are in a certain quadrant. So we draw a reasonable picture. Doesn't have to be super accurate so long as we see where we are in terms of the quadrant. So we are in quadrant 2, so let's draw some angle in quadrant 2. So this is our angle. Now the angle is called x. Don't confuse it with I wish it was called a theta or something, so that so perhaps for just sake of my practice here I will rename these things theta, so you don't confuse that x of the coordinate system with the angle. So so if you don't mind, I'm going to call this sine of theta is 2 over radical 3. So what was sine? You remember from our earlier days, sine was a ratio of opposite over radius. So what was that idea? Idea was that you have a triangle in whatever quadrant you want to be. This tip is some location xy, but this is x, this is y. And then the hypotenuse is r. If you have angle theta, sine of theta is a ratio of the opposite over hypotenuse, which becomes y over r. Then we said regardless of which quadrant you're in, you still use the same formula, except that now you notice that y could be positive, could be negative. Okay, after all of that, if sine of theta is y over r, it makes sense. Easiest thing to do is to assume that y is 2 and r is square root of 13. It's one of the possibilities, and it's just as easy as anything else for us. So I take this to be 2 and hypotenuse to be radical 13. What is left is to figure out x. So in this triangle, I say x squared plus 2 squared is radical 13 squared. So it becomes x squared plus 4 is equal to 13. That tells me x squared is equal to 13 minus 4, which is 9. And x could have been plus or minus 3. Well, which one? Well, that's where this information comes in handy. We are in quadrant 2. X therefore is minus 3. So here is all this work we did is to figure out this x is minus 3. You realize why I changed this from x to theta. So we don't go look for another name for our x-axis and call it something else. Okay, so we got x is minus 3. So what now? Well, by now we have sine of theta is 2 over radical 3. That was given. Cosine of theta, if I need it, let's just make a record of it. Cosine is, remember, cosine is x over r. X over r, the fact that this is minus now is going to be making all the difference. Minus 3 over radical 13. Tangent of theta, so remember, just as a reminder, this was y over r, this x over r, and tangent is y over x. So tangent is 2 over minus 3. Tradition is to put the minus in front or in the numerator. Either way, it doesn't matter. So we have sine, cosine, and tangent. So at the first round, we go and figure these things out, and then we come back and say, well, what is it that you want? First, I want sine of 2x. So let's go ahead. Sine of 2x. Well, what was sine of 2x? It was 2 sine x cosine of x. So this was 2 sine x, well, excuse me, I changed. 2 sine theta cosine theta. Sine theta. So 2 times 2 over radical 13 times cosine theta. Minus 3 over radical 13. Clean it up. 2 times 2 times minus 3. Minus 12. And denominator is 13. So that was easy. Same. Let me see if I can write it here. Cosine of 2 theta. We have many choices. In fact, we could answer cosine of 2 theta without doing any of this work, because I have sine already. Sine is given to me, and I could have used the following formula. Since sine is given to me, I could have used 1 minus 2 sine squared. So I could have used 1 minus 2 sine square of theta, and without having any additional information, I can say, okay, you already told me what sine is. It's 2 radical 13, and I have to square it. So 1 minus 2 times 2 squared, that's 8. And radical 13 squared is just radical 13. Take a common denominator and subtract. Becomes 5 over 13. Well, what if, let's just make some room here. What if you wanted to use some other formula? I could have used 2 cosine squared minus 1. That should give us the same thing. So I could also say 2 cosine square of theta minus 1. That would have then required for me to go find actually cosine squared. So I have to 2, this is minus 3 over radical 13. I square that and subtract 1. 3 squared is 9 times 2 is 18. Radical 13 squared is 13 minus 1. Take a denominator, common denominator, and subtract. You see that I get the same thing. What else do we want? We want tangent of 2x. Tangent of 2x, again, we have multiple ways of doing it. One is you have the sine, you have the cosine. Just take a ratio and you're all done. That's like the simplest thing to do. So tangent of 2 theta, I could have used sine of 2 theta. That was called what? The quotient identities, you remember? Okay, sine of 2 theta, I have it, minus 12, 13. Cosine, I have it. Here's my cosine. 5 over 13. And of course, these two cancel out. Minus 12 over 5 is what remains. Could I have done it some other way? Yes, I could have done it some other way, which is here's an alternate way of doing it. You want to get tangent of 2 theta. It's 2 tangent of theta over 1 minus tangent square. So let's do that. Also, just to say, so tangent of 2 theta is 2 tangent of theta, 2 of this, 2 tangent of theta over 1 minus tangent square of theta, 2 over minus 3 squared. Now you realize that was cleaner, faster, but no matter. I go ahead and simplify this thing, becomes 4 third. This becomes 1 minus 4 ninth. Multiply numerator and denominator by 9 to simplify the denominator. Multiply this by 9, you get what? You get minus 12. Multiply this denominator by 9, you get 9 minus 4, which is 5. And you notice we got the same answer. So we could get the answer in multiple ways, and it's good to try different ways and see that you get the same answer. Okay, the second problem is pretty similar. Let's do that too. I realized my not having enough space. So x terminates in quadrant 4. So again, let's to avoid any confusion, let's call this instead of x, let's call it theta. I am in quadrant 4. So I'm here. You can measure clockwise or counterclockwise. This is the theta. Its sine of theta, we said, is y over r. Y over r. So who is it that's negative? That is, let's draw it in some color. So this is -1. This -1 that you see here. And this is radical 10. That is the radical 10 in the denominator. So sine of theta, we said sine of theta is y over r, and so our y is -1. This one is radical 10. What we need to do is to figure out, well, how about x? What do I do to get x? I say x squared plus -1 squared is radical 10 squared. So x squared plus 1 is 10. So x squared is 9. X is plus or minus 3. Now I am in quadrant 4. So this thing that I'm measuring, this is my x now. X, it's important thing is to realize this is plus 3. So x final answer is plus 3 because I'm told I am in quadrant 4. Okay, what's the use of that? The use of that is I can make a list of everything. Sine of theta, y over r is given. Cosine of theta, x over r is 3 over radical 10. Tangent of theta is y over x. Tangent of theta is y over x. So y is -1, x is 3. So I have my 3 characters here: sine, cosine, tangent. Now what? Now if you want sine of 2 theta, sine of 2 theta, let's change color. Sine of 2 theta is 2 times sine cosine. 2 sine theta cosine theta. So that is 2 minus 1 over radical 10, 3 over radical 10, and this becomes minus 6 over 10. And if you want to clean up, minus 3/5, that's just as good. Cosine of 2 theta. As before, we can use multiple ways. One is just from the scratch information here, we could have just used this and be done. 1 minus cosine of 2 theta. Let me just remind you, 1 minus 2 sine square of theta. So I could have said 1 minus 2, whatever sign you gave me, which is minus 1 over radical 10, square that. So it's 1 minus 2/10. So that becomes what? 8/10, and that's of course same as 4/5. Tangent of 2 theta, we learned our last time, is best sine of 2 theta over cosine of 2 theta. My sine was minus 3/5, my cosine is 4/5, and ratio is minus 3/4. Did I have other options? Yes, plenty of them. For example, cosine, here's an alternate way. Cosine of 2 theta, I could have said 2 cosine square of theta minus 1. I have cosine here, 3 over radical 10, square that, subtract. And that is 2 times 9 is 18 over 10 minus 1 is 8 over 10, which is same as 4 over 5. Is that it? Well, there's actually another one. Cosine of 2 theta. So we are done. As if you notice, here's my sine of 2 theta, sine of 2 theta. Here's my cosine of 2 theta. Here's my tangent of 2 theta. We are done with the problem. We are just doing extra practice, saying that there are many ways of getting at the answer. It's not just these. So cosine of 2 theta, I could have used this identity instead of that. I could have used cosine square of theta minus sine square of theta. Practice all of them because each of them has a flavor of its own and comes in handy in its own place. So cosine is this. Sine was minus 1 over radical 10. You square them. Square of 3 is 9. Square of minus 1 is 1. 9 minus 1 is 8. Square root of 10 squared. Here is another way of, so 4 5, 4 fifths, 4 fifths, 4 fifths, these are all the same. For tangent also you have an additional option. Tangent of theta, what is it that we learned? It's 2 tangent of theta over 1 minus tangent square of theta. Tangent, we have to use that minus 1/3, 1 minus 1/3 squared, so it's minus 2/3, 1 minus 1/9, so minus 2/3 over 8/9, multiply numerator and denominator by 9, you get minus 6/8, divide minus 3/4. So this answer is same as that one you got here, and we got that one a bit faster. So it is essentially the same story being repeated over and over again. So again, let's call this thing theta. We are in quadrant 3. So I kept x as the name of this axis instead of angle. I'm in quadrant 3. This is my angle theta. I'll come up to here. Cosine of x, cosine of theta is x over r. X is my adjacent. So this is minus 1. This is radical 10. Is that right? Denominator is the hypotenuse, and that you either have adjacent or opposite, or x or y. Okay, we have gone through this practice multiple times by now. Hopefully you see immediately. Let me see. Do you see what is the number I should put for y here? So that's a question. The big question here, what should I put for y? Figure that out. Pause this video, figure this out, and come back. Okay, did you listen to me? Pause and figure it out. Minus 3. Okay, that's minus 3. So what is my, important thing is why is it minus? Because you're in quadrant 3. That's the big clue that we have here. Y's are negative here. Sine is what? Sine is y over r, so it's minus 3 over 10. Your x was, cosine was minus 1 over radical 10. How about tangent? The tangent is y over x minus 3 over minus 1, which is just 3. Okay, let's go after sine. Sine of 2 theta. 2 sine theta cosine theta. So sine 2 minus 3 over radical 10 minus 1 over radical 10. 2, 3, 1 gives us 6. Denominator is 10. Clean to 3/5. Cosine of 2 theta. Let me just use the fastest one. Cosine square minus fastest, meaning just directly from input I can get this without needing any of these. So 2 cosine of theta, which is minus 1 over radical 10 squared minus 1. So this becomes 2 over 10 minus 1, which is minus 8 over 10, which is minus 4 over 5. And the fast way of getting tangent of 2 theta would be sine over cosine So 3/5, here's sine, here's cosine, minus 4/5, and out comes minus 3/4. Okay, verification that you have two other ways of getting cosine, one other way of getting tangent. I leave that to you. And until next time, good luck and God bless.